we want to evaluate I, the integral from -1 to 1 of the square root of 1 minus x squared dx. And it would be really nice if there were like a 2x out front so that we could just use a substitution, but there's not, so we have to use a slightly fancier type of substitution. We have to do a trigonometric substitution. What was the clue we needed a trigonometric substitution? It was this square root symbol with something being subtracted or added on the inside. And so we want to make an edge of a triangle that has this length, the square root of 1 minus x squared. So there's a minus. That means this is not going to be the hypotenuse. If there were a plus, this would be the hypotenuse. If it were the square root of 1 plus x squared, then we'd have a 1 here and an x here, and this side would be the square root of 1 plus x squared. But we have a minus, and so there's a 1 here and an x here, and the length of this side is the square root of 1 minus x squared. And so what does that suggest for our substitution? Well, there's an angle theta in here, and sine of theta is equal to the opposite side over the hypotenuse, so sine of theta is equal to the square root of 1 minus x squared. And so we're going to come up with some kind of substitution. We're going to figure out what dx is in the theta coordinates, and we're just going to switch integrals, switch the variable of integration. From our triangle, and it didn't matter which side got made x or square root of 1 minus x squared, so these two things could be swapped, and we should still get the same value of our integral. But anyway, we take opposite over hypotenuse to get the sine, we take adjacent over hypotenuse to get the cosine, and we could also get the tangent, although we're not going to use it in this problem. So to figure out what dx is, we're just going to differentiate this, and we get dx is equal to sine theta d theta. Wait, that's not right. It's actually equal to negative sine theta d theta. So let's be sure to get that negative sign right. That's an easy mistake to make. And now let's go ahead and set up our integral. So the integral from -1 to 1 of the square root of 1 minus x squared dx becomes, it's going to be an integral, and that square root of 1 minus x squared becomes a sine theta, and then the dx becomes a negative sine theta d theta. And then what are our bounds? Let's see. We get -1 when theta is pi, and we get 1 when theta is 0. Obviously we had a ton of choices for what went here and what went here. This could have been 2 pi, this could have been 4 pi, this could have been negative pi. How do you know what choice to make? Well, we want to be moving from -1 over to 1 with our numbers, with our x numbers becoming positive. It would have been just fine to go from negative pi to 0 or from pi to 0. Those both have the same motion in x, but they're going to give us different signs to our answer, and so at the very end we'll just have to check, because we know that our answer should be positive, since this expression is always positive, and so whatever happens at the end, we'll just correct the sign to make sure that it's positive. Now we're going to need to do a substitution to deal with this sine squared, and we're going to use some trigonometric identities. We're going to use the cosine 2 theta identity, and we remember that cosine squared theta plus sine squared theta is 1, which is how we were able to transition to just sine squared in this expression. We solve for sine squared, and we get it in terms of cosine 2 theta, which is something that we do know how to integrate. So we're all set and ready to substitute. Okay, now we're ready to integrate. We can integrate this directly and this directly, so we're sort of splitting it up into two parts and doing those integrals. This is equal to the integral from pi to 0 of -1/2 plus the integral from pi to 0 of 1/2 cosine 2 theta d theta. This becomes negative 1/2 theta from pi to 0, plus, okay, well, we can integrate this, or we can recognize that we're going through an entire period of cosine 2 pi as we go from pi to 0, and so we know it will integrate to 0, but let's go ahead and do the integral anyway. Okay, and now we're ready to substitute in all our limits and find our final answer. This is equal to, we'll plug in a 0 and get 0, and then minus negative 1/2, so we get a 1/2 pi, plus we put a 0 in, and sine of 0 is 0, and sine of 2 pi is also 0, so plus 0. So our final answer is 1/2 pi, and that's positive, which is what we were expecting, and it's also the area of half a circle, which is actually what that function was, the integral from negative 1 to 1 of the square root of 1 minus x squared. This is what the function looks like, so 1/2 pi is the right answer.